Okay, so again, we've been given a derivative function, and we want to find the increasing regions of, and decreasing regions of slope, max, mins, and concave up and down. So we just talked about this fact that this vertex here is going to represent some sort of inflection point on the original f of x. Okay, so this is my f prime, and these max, mins on f primes give us inflection points. Okay, so let's draw in some parts here. Okay, so my f prime of x, okay, I'll do this chart here. The key points are going to be here and here. Okay, so at -3, we have a zero slope, and at +2, we have a zero slope. Okay, so when we look at this then, the y coordinates represent negative slope. Okay, so the negative y coordinates here represent negative slope. It's going to come across like this. The positive y coordinates for this whole region in between -3 and +2 is going to be positive, so it's going to be positive slope through that region. And again, we're going to get negative y coordinates here, so that indicates negative slope. Okay, so this slope chart gives me an idea what the graph is looking like. Okay, so I'm going to do a concavity chart as well, okay, or a second derivative chart. Okay, so what's important in second derivative? Well, it's whether it's sloping up or sloping down. And that zero slope, it means that the second derivative, or the slope of the slope, is equal to 0. Okay, so this is my second derivative is equal to 0. So then I just need to look on the slope of this graph. Where is the slope positive, and where is the slope of the slope graph positive? Negative, sorry. So the slope of the slope is positive from this region here, from the negative region. So then that means I have a positive second derivative, which tells me I have a positive concavity. And if you take a look at your graph above there, the slope chart kind of verifies the fact that we have positive concavity there. Here we have negative slope in the positive x values. So negative slope means the second derivative is negative, which then means that the shape is concave down on the original graph. And again, the slope chart kind of verifies that's the case. Okay, so this is what we're looking for. We're looking at the second derivative, and again, these are fairly typical problems where we're looking at the graph of the derivative. The graph of the derivative tells us slope, so the y coordinates tell us slope. The slope of the derivative graph tells us something about the second derivative, okay, which tells us about the concavity of the graph. So, looking at this one here, we have these points here. We have this vertex that has a change of slope on the slope, or change of concavity. We have 0 points on the graph, okay, which indicate the points where we have a horizontal tangent line. Okay, so let's take a look at this. So let's look at so f is a continuous function, and it's consisting of 3 line segments plus a semicircle in the middle. Okay, and this graph of g, this is f of x, which is a derivative of g. Okay, so this is a derivative of g. So find the local min and max coordinates of g. So what we want for the min and max coordinates is we need to know where the slope is equal to 0, or the derivative graph is equal to 0. So the derivative graph is equal to 0 at -1 and also +1. Okay, now we need to check the slopes. So it's positive slope, okay, where the x coordinates are all positive through here. Those are all positive y coordinates. So I meant to say y coordinates. When we hit the -1, we hit the 0 slope. Okay, so that's going to be that point right there. From here to here, these all represent negative y values. So from -1 to 1, the y values are negative, which means then that the slope is negative, okay, for that whole region. We hit a horizontal tangent here, And for this part, we stay negative. So we don't actually go to positive, we just stay negative. So this is what we would call a slide. Okay, so it slides there. Okay, so you get this, it kind of goes, levels off, and keeps going down. Okay, so that's our slopes. Okay, so we have an idea what the graph looks like. It goes up, kind of slides down like that. Okay, so what about the concavity of this graph? So we need to talk about the slope on the slope graph. And where does the slope change? Okay, so at -2, we have undetermined slope there. And it is going up to that point and down from that point. So it's positive and then negative slope. So what we have is positive slope on the slope, or positive second derivative. That means positive concavity. Here we have negative slope on the slope, or negative second derivative. So that means we have negative concavity. Okay, so that represents an inflection point. Okay, where else can we look for inflection points? Well, we have a zero slope here, right at 0. Okay, so there's a 0 slope there. And on the left side it's going down, and on the right side it's going up. So it's negative here, positive on this side. So it's going to change concavity again at that 0 point. So in this case, the minimum point on the slope graph represents a change of concavity. So we have another change of slope here at x equals 1. Although the slope is not defined at that point, okay, the slope of the slope, we don't have, it's a kink there. Okay, we do have this change of directions, going up and then going down. So now we have negative slope of the slope, or negative second derivative. So again, that represents another change of concavity. Okay, so there it is. We have our concavity graph now. So we know it kind of goes up, it slides, and we have a kind of change of concavity. So it ends up curving down, it looks like. Okay, so we end up curving down at the end. So this is going to be a little bit hard to draw, but we're gonna draw this graph. Okay, so we know that it goes from -2 to, from -2 we have positive concavity going up. Okay, at -2 we have a concavity change. It still keeps on going up, and then we hit a maximum at -1. Okay, so we had our maximum at -1. We're going to have another change of concavity. So concave down, concave down. When we hit 0, we're going to have another change of concavity. So now it's concave up, concave up. It's going to hit 1, and we're going to have it level off and also change concavity. Okay, so we have a 0 slope, but that 0 slope also represents a change of concavity because it goes concave down. And it goes concave down, concave down. It just keeps on going down because we have negative slope through there. Okay, so that's a potential graph of that function.